Enjoy those who are here in this room. The next talk. Let me tell you why we have all the kids here. Shashank, do you want to come here in the middle? This is one of the kind. Thank you very much. I think this is one of the kind opportunity for all of our younger generation to come and share their unique, talented on this stage. That's why I want all the kids to be here so that they can see how Shashank has done this tremendous job. Shashank Ravintula is here. He's 13-year-old. He has done lot of work on this topic. I think we all have to listen and enjoy a unique subject on this quantum physics and how this parallel with Eastern philosophy. If you give him a quiet moment, he can also tell you a lot of things which he like to tell. Please put our hand together one more time for Shashank Ravintula.
Should I start now?
Yes, you are
Good evening, ladies and gentlemen. My name is Abhishek Ravanuthala. I'm sure many of you already know that. And I'm here to talk to you about a very unique subject who many physicists have already done much work on. I'm going to try and draw parallels specifically between Vedanta, which is basically Eastern beliefs, and quantum physics, which is modern science. I originally came to be interested in quantum theory after studying Einstein's life, which led me to his special theory of relativity, which eventually in turn leads one to quantum theory. So I started researching that, and I'm very grateful for this opportunity to share what I've learned with all of you. Since my family speaks of spirituality a lot in the home, it inevitably rubbed off on me. So that's how I came to know about Vedanta. The Bhagavad Gita says, all actions take place in time by the interweaving of the forces of nature. The Chandogya Upanishad, which I'm sure many of you have already read, say that which is the finest essence, this whole world has that as its soul. That is reality. That is Atman. Tattvamasi. Here are some Vedantic thoughts that I will be emphasizing during this talk. Let's go over them now. A multitude of things and events around us are but different manifestations of the same ultimate reality called Brahman. Brahman is basically the substance of our universe, Eastern belief says, and it's supposed to be what makes up our universe. Number two, there is no objective world outside. The world we see is a projection of our minds. That means that everything that we see here, according to Eastern beliefs, is just what we choose to see unconsciously. It's not what's really there. Number three, time and space are mental structures and are illusory, or Maya. Maya literally means illusion. Everything in this world is interconnected and flows freely. I'll be revisiting that later. And the whole universe is engaged in an endless motion and activity. That is a huge part of this talk, and I will be definitely revisiting that later. Now, these are all very hard to reconcile with the original classical assumptions. In order to reconcile these, we first have to go back to the father of modern physics, Isaac Newton. I'm sure many of you have learned about him. He created our gravitation law and fathered all of physics. Now, since here are some Newtonian assumptions that cannot explain Eastern beliefs. Now, I say assumptions here and not principles because all of these eventually came to be in doubt when quantum theory came along. One of the first assumption made by Newton was that the whole universe worked like a giant machine or like a clock where all the motion is, though there's motion, it's always the same. It happens always the same. Given the same set of circumstances, the outcome will always be the same. Number three, we know a state of motion at one point, then we can predict it at a later point. That came to be known as determinism. I have an example of this. The position of a ball at point A is moving at 1 mile per hour, we can determine its future point in 1 hour at point B would be 1 mile away. We can predict that point based on that law, or what was thought to be a law at that time. That would be determinism. We can also determine its past or future points at any given point using simple mathematics. Now, things are about to get really, really weird once we get into quantum theory. Here's some quantum quotes, if you will, that I've prepared. Those who are not shocked when they first come across quantum theory cannot possibly have understood it. That's when Niels Bohr, 1922 Nobel Prize. I think I can safely say that nobody understands quantum mechanics. So Richard Feynman, 1965 Nobel Prize. Now, the first odd part of quantum theory is that it doesn't apply, is that Newtonian physics don't apply to subatomic particles. Now here I have to explain what subatomic particles are. They're simply, some of you may already know, they're simply particles on the inside of an atom, such as a proton or electron, or neutrinos, anything on the inside of an atom. Another principle of it is that probability governs it, meaning what we see is actually based on probability. Out of the infinite possibilities, actually what we see is completely based on probability. That's, if any of you have heard of the famous Einstein-Bohr debates, that is why Einstein had such a huge problem accepting quantum mechanics, because he didn't believe that our whole universe would be based on probability. He had a famous statement, God does not play dice. A quantum particle does not exist in one state or another. In fact, it exists in all states simultaneously, which is, if you think about it, is very weird. How can I be here and there at the same time? But somehow, quantum theory actually accurately predicts almost everything, even closer than what Newtonian physics does, but only for subatomic particles. This is something called observer's paradox. Only when we observe any quantum state does, out of all the infinite possibilities that are actually happening simultaneously, do they break down into a single possibility that we view. In fact, the fact that they're all happening at once is called a superposition. Meaning, I'll give you an example. If I'm here and there until observed, that's actually true, is what this is saying, and that's my superposition. But since you're observing me, your mind breaks it down into a single position which they can comprehend, which is in alignment with Eastern beliefs, which say that the mind just categorizes everything, the immense universe, into small packages that we can understand, which isn't very much. So this is in alignment with Eastern beliefs. I have an example of this. This is a famous experiment. Now, there's no need to worry. No cats were harmed in the making of this experiment. In 1935, a famous physicist named Erwin Schrödinger proposed a thought experiment where he placed a cat in a box with a sealed vial of poison and a Geiger counter. A Geiger counter is just a counter that measures radioactivity or radiation. Now, there's a hammer over the vial of poison, and it's attached with a string. Amount of radioactive material here. If it decays, the Geiger counter would go off, allowing the string to cut the hammer, falling on the vial of poison, breaking it, killing the cat. Now, since it is in a sealed box, we cannot see this. So, in fact, according to the Copenhagen interpretation of quantum physics, which means that every possibility is happening simultaneously, this means that the cat is both dead and alive until observed. This is another example of observer's paradox. In fact, the state of being both dead and alive is called its superposition. In fact, it's not just being dead and alive, it's being everything at once. That would be its superposition. It is a reiteration of what I just explained in text. Here's revisiting some Vedantic thoughts that will now be further discussed. Everything in this world is interconnected and flows freely. The whole universe is engaged in endless motion and activity. These will be further emphasized in a minute. Here is a contrast, and alignments between spirituality and science. Nataraja's cosmic dance, or Shiva's cosmic dance,